So we're going to be talking about how to deal with graphing a system of linear inequalities. So the first thing you have to deal with when you're graphing a system of linear inequalities is whether you're going to be making a dotted line versus a solid line. So the easiest way to notice it is based on the equation. You're looking at your equations, looking at these symbols. Now those symbols tell me whether I'm dealing with dotted or solid. Anything that doesn't have an equals bar underneath, like these two, I'm going to graph with a dotted line. Because technically what this is saying is the equation can get super close to y, but it actually can't be the same thing. So the line doesn't exist, but we need something to be able to graph our system with, so we make it dotted just to show that. Anything with an equals bar is a solid line. Because y could equal 4x plus 2. So there we actually do need to include those points. So that one we make a solid line because it does exist in our picture. So starting off super basic, just a single linear inequality. You graph it just like you would any other equation. So in this case, y equals mx plus b, my y-intercept is 1. So I'm going to start there. My slope is negative x, which we know actually means negative 1x. So down 1 over 1, down 1 over 1. And since this is a solid line, I'm going to go make a solid line. Now we're not done because it's an inequality, which means that I'm talking about more than just the points on the line. I'm talking about all the points on one side of the line. Easiest way to figure out which side of the line I'm talking about is based on a single point. So I always pick any point I think of first, which usually is 0, 0 if it's not on the line. So in this case, 0, 0 is not on the line. And I'm going to use that point to test and see if it makes our equation true or false. Now, what do I mean by true or false? Well, true meaning if I were to plug in 0, 0, it makes this statement work out to be something that's actually factual. So let's test it out. So I plug in 0 for x and 0 for y. So when I simplify, I get 0 is less than or equal to 1. Then I have to decide, does that make sense? Is that a true statement? And it is. It's true. So that means that every single point on this side of the line would also be true. If you want, you can test a few more, but there's no reason to. Once I know one side of the line is true or false, I shade it in. So that means any point on this side of the line, anything over here, would make that statement work out to a true statement. You can also test on the opposite side of the line and see what happens over there. So I'm going to just pick a point and show you what happens. You don't have to do this every single time. So I'm going to pick the point 2, 3. So if I plug it in, I end up with 3 is less than or equal to negative 1, which is false. Because 3 is not smaller than negative 1. So that means all the points on the opposite side of the line wouldn't work, which is why we don't shade them. Now what happens when I have two equations and I have to graph two different systems and shade in two different ways? Well, it's pretty straightforward. It's basically the same thing. So we'll skip over this one because I don't like that first equation. We'll go here. So start by graphing your lines. We'll start with the top one. Y is less than or equal to 1/3 x minus 2. My y-intercept is negative 2. My slope is 1/3, so up 1 over 3. And this tells me I need a solid line. Then I'm going to do the same thing with the other equation right away, and I'll come back to whether or not I need to where I need to shade. So my y-intercept is 1. Change the color here. My slope is 4/3, so up 4 over 3. That should be a dotted line. So right here, this symbol tells me it should be dotted. Okay, so I've got my two graphs on the plane. Now I need to figure out which sides of the lines for both of them I'm going to shade. So I would pick a point, any point that I want. I like to pick 0, 0 because it's the easiest. You could pick really whatever you're interested in. So I'm going to try 0, 0. If I plug it in here, picking 0, 0 to test it out, 1/3 times 0 minus 2. So that simplifies to 0 is less than or equal to negative 2. True or false? 0 is not less than -2, so that is false. So that means for this top equation, this one here, 0, 0 is false, which means every single point on this side of the line is false. So I have to shade in the opposite direction because that must be the true side. So down here. So shading all of this space. Now I'm going to plug that same point into my blue equation and see what happens there. So I'll plug in 0, 0 over there. 0 is greater than 4/3 times 0 plus 1, or 0 is greater than 1. Again, it's false. So that means for the blue equation, the side with 0, 0, so this side of the line is all false. So I have to shade on the other side of that line. And what I'm really looking for is any place where the shading would overlap. So if you're looking at the picture, it's kind of hard to tell with this one where the shading would overlap. That's why I like to do it in 2 colors. But after a little bit of looking at it, you probably noticed that right over here in the corner, this little region here, I shaded both red and blue. That would be our solution, because what you're looking for is where would it be true for both equations? In this case, down in that little corner. Well, let's try that again. Starting fresh. All right, 2 equations, graph them first. So I'll do down 2, slope of 1/3, and a solid line. Top equation. Top one is going to be red. Bottom equation has a y-intercept of 2, slope of 5/3. So, and again, solid line. Now, blue. So got my lines graphed. Got to pick a point. So I check. My favorite is 0, 0 because it's the easiest. I'm going to plug in 0, 0 to both equations. See what happens. So we'll start with the top equation. If I plug in 0, 0, I end up with 0. It's greater than or equal to 1/3 times 0 minus 2. So 0 is greater than or equal to -2. True or false? Is 0 bigger than -2? And it is. So for my red line, 0, 0 is true. So that means I need to shade towards 0, 0, towards the point that I picked. So shade that in. I don't like to shade too dark because it makes it hard to tell where everything else is. So I usually do it really lightly if I'm working with pencil. Checking in the other equation, 0, 0. So 0 is less than or equal to 5/3 times 0 plus 2, or 0 is less than or equal to 2. Again, true or false? Absolutely true. 0 is bigger, or 0 is smaller than 2, like it says. So again, I'm going to shade towards 0, 0. So my picture, this way. Once I've done that, I take a minute and I see, where did I shade both red and blue? Wherever that happened is where my solution is. So in this case, it would be right here. Shading both of those colors in there. All right, so while you're going through and working on these types of problems, it's important to make sure, first of all, that you're graphing correctly, your y equals mx plus b format. It's also going to be super important to watch your symbols, whether it's the less than or equal to or the less than and greater than. Once you have your dotted line, your solid line figured out, and you figure out your shading, we're always looking for where they overlap. If they don't overlap, you don't have a solution. Or if they overlap everywhere, then everything is a solution. But normally it's just going to be like 1/4 of the graph, kind of like what we have here. So I hope this helps.